Hi all, a very good evening and sorry for being so late in uploading a new video. So today I will just continue from wherever I have left in my last video. So there I have explained some important statistical tests like t-test and z-test, but those are mainly used for checking the data distribution of continuous predictor variables. But whenever it comes to any categorical variables, we can take help of chi-square and ANOVA. So when chi-square is used, when both my predictor and target variable are categorical, in such cases we can use chi-square, and when my predictor is categorical but my target variable is continuous, so to check the relationship between such variables we can take help of ANOVA. So now I will give a brief overview of chi-square test, how it is performed and what all factors we need to consider. So the chi-square is a non-parametric test which is used to determine whether there is a significant relationship between two categorical variables, or in mathematical terms we can say that whether the observed frequencies differed from expected frequencies or not. What is observed? Observed means the actual frequency, and expected means what is the theoretical count. So basically what are we predicting, that is observed, and what is the fact or real data, that actual data, that can be called as expected. So to compare the frequencies of these two segments, we can take help of chi-square. So why it is used, as I have just said, that to compare the observed frequencies with expected frequencies under some assumption of independence of certain distribution, this chi-square test is used. And also it is used for doing feature selection in while building any machine learning model, and also to evaluate the model performance. So if for such scenarios chi-square test is widely used. So if I give you some areas where this test can be seen in use, such as market research, healthcare, social sciences. So all these data are very much what should I say? To analyze such kind of data, we can take help of chi-square test. If I give you a short example, that is gender related to color preference or not. So I just want to determine whether a particular gender is fond of any particular color or not. So to check the relationship between these two categorical variable, I can take help of chi-square. Now I will show you a small mathematical example just to explain that how we should perform the chi-square test theoretically. So here my problem statement is, there is a health survey where people are checking whether any smoking habits is dependent on, whether there is a relationship between the smoking habits and the exercise pattern or not. So whether smoker, so there are two type of smoking habits, smoker and non-smoker, and within exercise category we have three type of exercises: regular exercises, occasional exercise, and no exercise. So I just want to see if the pattern of the exercise shed any effect on smoking habits or not, or vice versa, that whether the if a person is smoker, whether he or she is prone to do the regular exercise or occasional exercise or no exercise, like that kind of observation we want to see from this problem statement. So what will be my first step? The first step will be to determine null hypothesis and alternate hypothesis. So my null hypothesis will be smoking habits and the frequency, exercise frequency are independent, which means there is no relationship between these two variables. And what is my alternate hypothesis? Alternate hypothesis is just the reverse, that they are dependent. I mean there is some relationship between this two variables. Now what will be my step 2? Step 2 will be to calculate the chi-square value for each cell in the contingency table. So here you can see I have 2 rows and 3 columns. So now I have to calculate the chi-square value for each of this cell. So suppose if I take an example of a smoker person and who is doing the regular exercise also. If I want to check the chi-square value for this cell, the first cell, then how will I do? The formula of calculating chi-square value is observed frequency minus expected frequency square divided by the expected frequency. So how to calculate the expected frequency of any particular cell? You have to just multiply the row total and the column total and then divide it by the grand total. So here if you see, for the first cell my row total will be 100. I mean I have to first calculate the row total. So my first so I am considering the smoker category, so the row will be this. So what will be my row total? It will be 100. And what and which category I am considering? I am considering regular exercise. So what will be my column total? So column total will be this, which means 80, and I have to divide it by the grand total. Grand total means whatever records are there, I have to just sum up and I will get 200. If you sum up this thing, you will get 200. So now my expected frequency for my first cell will be row total, which is 100, then multiply by 80 divided by 200. So this is my expected frequency. Now what is my observed frequency? In my first cell the observed frequency was 50. Sorry, I was actually I was calculating for non-smoker and regular exercise category, but mistakenly I have told smoker and regular exercise category. No issues, you can do for any cell, but I have shown here for non-smoker and regular exercise. So here my observed frequency, if I have as I shown you, it will be 50. So my observed frequency is 50. Now I can calculate the chi-square value easily. How will I do? I will just I subtract 40, which is my expected frequency, from 50, and then I will just square it, and then I will divide it by my expected frequency, which is 40, and I will get the value as 2.5. So for a particular cell I got the chi-square value. So like this you have to find the individual chi-square value of each of the cell in the contingency table, which is given to you within the problem statement. And when all of the individual chi-square values are calculated, you have to sum up them. So after calculating individually for all 6 cells, I got the sum as 8.42. Now my step 5 will be to determine the degrees of freedom. So what is the formula for calculating degrees of freedom? It is nothing but you have to multiply the number of rows minus 1 with number of columns minus 1. So here I have 2 rows and 3 columns, so my degrees of freedom will be 2. Now the final step, which is to find the p-value and compare the chi-square value with the critical value given in the chi-square distribution table for a particular DS. If you search the chi-square distribution table in Google, you will get to see there will be a table where there will be multiple critical chi-square value given with respect to different degrees of freedom. So from that you can just refer for a particular degrees of freedom. So here my degrees of freedom is 2. So for 2, what will be my critical chi-square value? So from that table I got that with degrees of freedom 2, my critical my chi-square critical value at alpha 0.05 will be 5.991. So I have to now compare my calculated chi-square value, which is 8.42, with this critical value, just to determine whether I should reject the null hypothesis or fail to reject the null hypothesis. So if you see here, my calculated chi-square value, which is 8.42, is greater than 5.991, which means my p value is less than 0.05. And so what will be my final conclusion? Since my p value is less than 0.05, then we reject the null hypothesis. So what were our null hypothesis? We told that there will be no relationship between the smoking habit and the exercise frequency, but we had to reject it because of the final output which we received after the entire calculation. So here we are rejecting our null hypothesis and we are accepting the alternate hypothesis. Actually, we cannot say that we are accepting null hypothesis, because any kind of hypothesis you perform, you cannot, deterministically say that you are accepting something. You say either you rejecting a hypothesis or you are failing to reject any hypothesis. So here we are failing to reject the null, alternate hypothesis. So that is why we can finally conclude that the smoking habit and the exercise frequencies are interdependent. If someone changes their smoking habit, if someone changes their exercise pattern, then their smoking habit can also be changed or varied. So I hope that this example has given you a clear view of how to perform chi-square test theoretically. And when you perform any machine learning model, there you just need to import the package, the chi-square package from the from a Python library, and you can just call it on top of your raw data and you will get the final chi-square value. So from that you can just compare whether your chi-square value is within the rejection criteria or the acceptance criteria. Now my next test is ANOVA, which is called analysis of variance. So what is ANOVA? The ANOVA test is used to determine whether there are statistically significant differences between the means of 3 or more groups. Okay, so here basically, as I have explained you earlier when I was starting my video, that for check the dependency of two categorical variables, we can use chi-square test. But when there are more than 3 groups and we want to compare the means of all the groups, for such cases we can perform the ANOVA or analysis of variance. And also when there is any continuous predictor variable given, suppose I have 3 age group, I have my gender and I want to see whether there is a relationship between the gender and their earned salary or not. So salary here is a continuous target variable, but my predictor variable is categorical. So for such cases also we can take help of ANOVA. So that is why ANOVA helps us to check if any group mean is significantly different from others instead of doing multiple t-tests. So in t-test also we have compared the means of different groups, right? But here we can do it for more than 3 groups simultaneously, but in case of t-test you have to perform it separately. So that kind of effort you need not to put here. So that is why ANOVA is quite significant here. So basically ANOVA takes help of F statistics or F test to determine the final outcome. So what is the value of F statistic? How to calculate F statistics is nothing but the variance between the group divided by the variance within the group. Means if there are 3 groups, so I will just calculate the variance of individual groups and then I will also calculate the variance within each group. So then we have to divide these two values to get the final F statistic output. Now how ANOVA works? So basically ANOVA divides the total variability into 2 parts. As I just mentioned in the F statistics formula, we have to calculate first the between group variance due to differences between means, and within group variance due to random error or individual differences. When these 2 values are calculated, then you can just put it in the F statistic formula and you will get the F value. Once you get the F statistic value, by looking into it you will able to understand what does it actually signify. If the F value is large, which means the numerator is high, which is the between group variance is higher than the within group variance, then there will be likely a significant difference between the different group means. And likewise you can analyze all the F values properly by looking into it. But to get into the conclusion that whether you should reject the null hypothesis or you are failing to reject the null hypothesis, you have to compare the calculated F value with the critical F value which you will get from the F distribution table, just like we have done for the chi-square example I have shown you just before this. So there we calculated the computed chi-square value with the critical chi-square value. Here also you need to compare both the values and you have to see whether the calculated value is greater than critical value or less than critical value, and based on that you can accept or reject the null hypothesis. You can also use the p-value concept. So many ANOVA test. Now I have explained you all the tests like t-test, z-test, chi-square and ANOVA, and I have given you some small mathematical examples also. Now you may have the doubt that where to use which test. So here I will give you a brief idea for that. So as I said, t-test is basically for the numeric data, and when you have small samples like less than 30 and you want to compare 2 means, so in such scenarios you can use t-test. Z-test is also for numeric data, but you perform it when you are having large samples and you want to compare the means, and here the variance and standard deviation, such parameters will be known, but in t-test you won't be getting such parameters. Chi-square is for categorical data, for comparing the the relationship between 2 individual categorical variables, and to check whether there is any dependencies between the observed frequency and expected frequency. We can take help of chi-square, and can also help in checking goodness of fit of any ML model, as I have mentioned you, by checking the relationship between the predicted variable and the actual variable. ANOVA I have just explained you. It is basically helping you to get the relationship between more than 3 group means, and also between the categorical independent and continuous dependent variable. Now we have come to the conclusion. So I hope that I have given you a fair idea of all these statistical states which are widely used for any data analysis and machine learning use case building. So now when you are doing any data analysis or EDA, that is exploratory data analysis for any ML model, you will get to know where to perform which test, and for which variable which test is suitable. So like that you can solve many complex real life problems, and you can easily understand the data distribution of any kind of data, be it complex or simple. So that's all for this video. So, and that's all about the statistical test. If you need any further information on this topic, please let me know in the comment section. I'll definitely try to create a video on that topic. And also let me know how do you feel about my teaching, whether it is understandable or not, whether I should go I should reduce the pace or I should increase the pace, and I should explain you more theoretically or practically. Just let me know everything, your thoughts. You are open to share your thoughts actually. So yeah, thank you for listening to me. Have a good day ahead, and I'll get back to you soon with a new video and a new topic. So yeah, thank you. Bye bye everyone.